So today we're into 6.2. 6.2 is all about LCMs. So I'm guessing most of you, if not all of you, will remember that stands for least common multiple. So we'll start off with some numbers, and then I'll give you the strategy later, but let's just see if we can do it without even a strategy. Somebody on these tell me LCM is 35. This one would be a 24. This would be a 36, and then let's call it timeout and think strategy. So sometimes people's strategy, I think, is the numbers just come to me. And that's nice, I guess, if the numbers just come to you. But I don't know that that's a really good way to educate America, is just say, hey, America youth, I hope the numbers just come to you. Okay, if they do, great. But if the numbers aren't just coming to people right away, can anybody explain a way that you can generate these numbers other than, I don't know, the voice in my head just told me?
It's the smallest number that they both go to.
That's true.
It's just like, you can always just multiply them together, but that's not always the LCM.
Yeah, we could. That only works for this one. So the highest you'd ever have to go is this times this, made that. But like 6 times 8 is 48, and we settled for 24 as better than 48. So if you did multiply them, that does kind of give you the ceiling of the highest you could go. Anybody have a thought on how you could plot the lowest you could go other than like they just appear to me in my brain? Like, is there a process by which anybody can do that?
I just kind of make lists of like the times tables of both of them and
Yeah.
then find what's in common.
Yeah, we could do that. I'll streamline that even a little bit for you, but yeah, what you could do is in your mind just think through 12 and 24 and 36 and 48, and just sort of count by 12s and make a list either on paper or in your mind, and then also count by 18s in paper or in your mind until you find somebody in both lists. That is certainly a strategy that works. A strategy that I'll use to do this is I'll focus on the bigger number, because the bigger number is going to have a shorter list. They just come faster. So I would count by 18s until 12 cooperated. So 18 itself, can 12 go into 18 itself? No. So 18 times 2 makes 36. Can 12 go into 36? Yeah, so there's my hit. If it didn't work, I'd have done 18 times 3 and 18 times 4. I'll usually go bigger number, times 1, times 2, times 3, times 4, times 5, until the little number will cooperate with me. So here, if we count through our 24s, we'd have 24, then 48, then 72, then
I didn't go with my common tables. I use a calculator.
96. Does 18 do any of those yet?
Probably not.
12, or excuse me, we said 24, 48, 72, 96. Use a calculator if you need to. Can 18 do any of those numbers?
72.
72.
Oh.
I was thinking that.
It was not 96 because 8. I can't name one thing I hate 96.
48s. Go through your 48s. 48 times 1, 48 times 2, 48 times whatever, until 36 will play with you. Somebody get it. Use your machinery if you need to.
Anybody got a calculator, yo?
44.
It is 144.
She had a calculator.
Try this. You got your machine. I think this works, but let me try something. Do punch 36 times 48, and then divide by 12. Would that work?
144.
Yeah. All right. So I've got another scheme up my sleeve then, if you don't like my first scheme. 60s, just count through your 60s. Sooner or later, 35 will play with you, but it's going to be a while.
You know. Sorry.
No, 35 won't do 120.
540.
540.
Maybe. I think I've got one smaller than that. 420, I think, is the hit.
I think I found the trick I just saw.
What's that?
Multiplying it and then using GCF.
So Aubrey spotted my trick. On this, after I did 36 times 48, why did I divide by 12? I didn't pull that up. It's the GCF. So another scheme you could use is just multiply the numbers, but then divide by the GCF. So like, multiply these is 48. Who's the GCF? 2. So divide by 2. Multiply these, and then divide by 6. Multiply these.
9.
No.
Oh. I thought that was a 7.
No.
I thought it was a 7.
Or 6.
Listen to me.
Divide by 6. Multiply these, and then divide by 5. So if you're good at GCFs, multiply the numbers,
No, it was a 7.
divide by the GCF. That won't work if you have 3 numbers though, I don't think. I think 3 numbers, we'd have to count through our 48s until everybody plays with us. Somebody?
Who's doing it? I'm leaving that one to Nicole or us.
Isn't it 72?
No, 48 won't do 72.
Isn't it just
Or-
48?
9 won't do 48.
Oh, that's
144.
9. I thought that was a 40.
No, that's a 9, sorry.
See, girl, we
So,
the same thing. I'm
9, 12, 48.
144.
144 is going to be our hit.
I got it.
48 times 1 is 96, or 48 times 1 is 48. 9 wouldn't do that. 48 times 2 is 96. Does 12 do 96? Yeah, but 9 doesn't. So 48 times 3 would be the hit. Question about dealing with numbers? Okay, the book will give you none of that advice. Okay, most books don't. I don't know that I've ever seen any of those in a book. So here's how the book will tell you to do this: is to factor the numbers,
I love it.
and then take each factor the most it happens. In one of them. That's good advice if you've got algebra that we're going to factor, which we will. That is how we're about to do all these algebra ones. But I would not recommend that to anybody, although it's true. I wouldn't necessarily recommend to anybody to list 5, 10, 15, 20, 25, 30, 35. And list 7, 14, 21, 28, 35. I wouldn't necessarily recommend to anybody make both lists and look for who's in common, although that works, because I just don't want to spend the time making lists. I would recommend either the number comes to you from heaven, or multiply the numbers and divide by the GCF, or if you do want to make lists, only make lists of the biggest number until the other ones work. Because here, would you really want to list 9, 18, 27, 36, all these numbers that don't even matter, that aren't even close to 144? And just list the bigger numbers list. That's not too bad. But what they have in mind is this, is take something like 35, and when I say factor it, I mean do this. 7 and 5. We take 60, and we do something like this. 10 and 6, but 10 breaks down 2 and 5. This breaks down 2 and 3. So this has 2 2's. So we would need to multiply 2 2's eventually. What else do we have? A 3. The most we ever saw is a 3 in one of the answers, so take a 3. Take a 5. This has a 5, this has a 5, take a 5. We also have to take a 7. If you took 2 times 2 times 3 times 5 times 7, you would get the 420. I would not recommend that as a way to do this. Okay. Is it true? Does it work? 100%, yeah, but that's a lot of water. I don't think you want to make a lot of factor trees, but it works. So how do you do LCMs and numbers? Pick a system. Make 2 lists. Make a list of the biggest and try the littlest. Hear from heaven. Make factor trees. Multiply them together, then divide by the GCF. I don't care. You do what works for you. You do you. Pick a scheme. I gave you 5 ways. Question about LCM? When we make the jump into algebra column, we are going to have to obey this. There's no other way to go. We're going to have to factor, hence the factoring quiz we've taken 12,000 times. And then we're going to pick each factor the most that it happened in one of the factorings. So here, 12 and 18, do what we did over there. Hear from heaven, make lists, do something. 12 and 18 gives us 36. Then for the x's, take the most that you see. What's the most x's you see at one place in one time? 3. What's the most y's you see?
2.
2. We're just taking everybody the most. That's how we handle the algebra stuff. Question about that scheme? So 24, 36. Who is their friend? 72. I would think through my 36s, 24 goes into the second 36, which is 72. X's? 3 is the most I see. Y's? 4. Z's? Also 4. That's your LCM. Question about that. Anybody shrewd enough to know why are we doing LCMs for a day? We're going to be doing something worse, is right. When in math have you used LCMs in your past? What did we do yesterday with fractional things? What did yesterday's homework do? Multiplied, straight across. Divide, what did divide make us do? Flip second fraction and go. Did it seem strange to anybody they started with multiply, divide? I thought that was strange.
Maybe adding and subtracting.
Yeah, because adding and subtracting fractions, what do you need?
Same denominator.
Common denominator. How do you pick a common denominator? LCMs. That's where this is going. Okay, so we're going to add subtract probably tomorrow, but LCMs have to happen first. So that's why this is popped in here. 3s, 8s, 16s. I would count through my 16s. 16 times 1, 16 times 2, 16 times 3, 16 16s.
32.
Until all of those numbers are going to cooperate with us. 3 won't cooperate with 30.
Oh, there's 3 up there?
Yeah.
Oh, I didn't see that.
I was hiding that third one. 48. X's. 5. Y's. 2, because everybody had 2, so not a really difficult race. Z's. 7. Again, if you missed it, most is the word of the day. Whatever it was, the most times you see it, that's who you take. Somebody, something about that? When we get into the world of parentheses, if the parentheses are in our list anywhere, we have to take them. Then the question just becomes how many times. So how many different things do you see on this one? 2. What's one thing you see? X plus 3. X plus 2. We have to take those both. If you see it, you have to take it. It is unavoidable, you're going to be taken. The question becomes, do you need powers on either of those? Does either of those need a power? How much power? Squared. Why squared? I see 3 of them.
Because there's 2 on the same side.
There's 2 in a group. It's the most that you see in a group. We didn't go here and think 3 versus 5 versus 2, let me take like 10 of those. No, we saw 5 of them there, so we took 5 of them. On this, x plus 2 happened doubly here, so take 2 of them. The fact it's over there, it doesn't really do anything for us. This one, how many different things do you see? 3. Some people would argue for 4. I would say, no, there's 3. How did I disguise?
One's x plus 2, one's 2 plus x.
This is the same as this. If you add or if you subtract it out of order, we're going to count those as the same. Adding out of order is the same. For LCM purposes, subtracting out of order, also the same. So 3 different things. One of them would be
X plus 2.
X plus 2. Or if somebody else wanted to, they could have said
2 plus X.
2 plus X. Just pick one. You don't have to do both of these. Just pick either one, doesn't matter. As well as
X plus 3.
X plus 3,
X minus 3.
X minus 3. Next one. How many different things do we have?
2.
2. This is the same as this, adding out of order. This is also considered, for LCM purposes, the same as that, subtracting out of order. We're not going to count those as different. What happens if you subtract out of order? What's it do to the number result? It just makes it negative. So if I had popped up here and made one of these numbers negative, you still would have settled on 72. It's just now, like, what do you want to do with the sign? It's just sort of weird. But you wouldn't really worry about that too much. So this, we just need to take two things. They're subtracting out of order. That would switch a sign of something, but for today, no one cares about that. So one thing possibly could be
X plus 7.
X plus 7, or 7 plus X. The other thing could be
X minus 8.
or 8 minus X. Doesn't matter, you just pick it. Something there. Bottom level, numbers. That's a squiggly 5, sorry. That's a 3 over there where my chalk skipped a little bit. With 3s and 5s go 15. And then how many different groups do you see?
3.
3. X,
Plus 2.
that's there.
X plus 4.
That's there.
X plus 5.
And then the only real choice is, I saw this one twice. So should I do a power on it?
No.
No, because you didn't see it twice
In the same group.
in the same group. They have to be in the same group to get the power. Question about those? Why was I taking it a little bit easier on you there than I'm about to through this last little squiggly column in the corner? Maybe, but like, why were those easier than these? We have to factor this ourselves. So over here, I factored it for you. Maybe they'll do that sometimes, maybe they won't. Maybe I just did that to speed the lesson up. I don't know. But for sure in the homework, you're going to have to do some factoring. So here, how would this one go?
X plus 4. X plus 1.
X plus 4, X plus 1. This one?
X plus 8. X plus 1.
X plus 8, X plus 1. So for our LCM grand total, how many different things did we just encounter?
3.
3. What are they?
X plus 4.
And do we need powers on any of those?
Nope.
No, because they only ever happen one at a time. Something about that. Factor again. This one?
X plus 3. X plus 3.
X plus 3 and another X plus 3. This one's
X plus 2. X plus 3.
X plus 2 and X plus 3. How many different things did we just encounter?
2.
2. Who were they?
X plus 3 squared.
X plus 3, which is squared,
X plus 2.
X plus 2. And this time you had to do the power because
It's on the same side.
it's on the same group. These two have a thing that from the factoring quizzes and from the tests, people don't always like to do first. So when you do the factoring quiz in a minute, what's the thing we try to take out first?
GCF.
Always look for GCFs first. Don't just jump in and do something. So who's coming out of this?
5.
Okay, if we do that one, yeah, 5. And then if I go x squared plus 2x plus 1. Can somebody break that down? It is x plus 1, either squared or just write 2 of them, however you prefer to do it. Doesn't really matter to me. But we'd get a 5, and that would break down to that. Who comes out of this one?
4.
4. X squared minus 1. Break that down.
X plus 1. X minus 1.
X plus 1, X minus 1, that's a difference of squares. So grand total LCM number?
20.
20 is who they go into. How many things did you see?
2.
2, X,
Plus 1.
and
X minus 1.
does either of those get a power on
X
it?
plus 1.
The X plus 1 gets
2.
2. That's what today is about. So if there's numbers, again, we had a lot of strategies for the numbers. When we get into anything with algebra, variable kind of things, get it factored, and then take everything the most that you saw happen. Question about any of that? Let's quick look at homework. We'll do a few minutes on the 249 page, and then we'll leave some time to take our little quiz. So odds are all in the back. If you want to check your odds, you could know if you're on a good or bad track. Let's first just do anything that people started and you just got a little bit grouchy about.
Really bad.
Anybody have anything on 249 that as you did it, you had a moment that made you say, uh-oh, or I don't know about this. I hope this is right.
Find my folder that has.
Anybody have anything that got you stuck? Our cameraman's gonna be mad at you.
I know.
We're good.
No questions on that? You got something?
26.
26, okay, that's a nice hard one. This is also a good one to set up our factoring quiz in a minute, because this is going to give us a whole lot of factoring sort of stuff. So 26. So somebody, anybody, can we factor that first top on 26?
Yeah, 2x minus 3y, 2x plus 3y.
Yep, so 2x minus 3y, 2x plus 3y. This is out, that other stuff's in. Does anybody need any detailed explanation on how that just happened? Okay, so let's go bottom. And bottom factor,
Yeah.
okay?
2x minus 3y.
Yep,
And then 4x squared plus 6xy plus 9y squared.
yep. That's a cube. Does anybody need a little bit of detailed help on how to factor a cube?
God.
Yeah. So we're going to go cube root that number, divide by 3. Copy the sign. Cube root the number again, divide by 3 again. So with that,
Yeah, I don't know how to get
okay, then we go here times itself. This times itself will go first. This times itself will go last. That's always a plus last. This will just go a different sign to mix it up. And this middle guy is just that times that. If we multiply them, it has 6x. Good on that? Anybody need help on the first two factors? This, you could try for a little while to factor this, but you're going to get a little frustrated because you can't. But it's okay if we pay attention to our surroundings. This is invisibly like it's in parentheses. Why is this not at all a long-term issue for us? Anybody at all see why is this not really a long? It cancels this other one. This is a perfect match for this. So if you just notice that those are twins, they just flush. While we're in cancel mode, do we have anything else that could cancel yet? 2x minus 3y. Then, does this seem like it might factor?
You could also, yeah,
Maybe, maybe not.
because it's 2x plus 3y squared.
And if you just pay attention to your surroundings, it seems likely if an author of a book is doing this stuff, they're probably going to work this in so that it'll cancel. So use a little bit of human psychology. The book authors probably like to show off their canceling skills. This is 2x plus 3y factored with another 2x plus 3y. Sometimes on these lessons, if you just think like an author, this was a tip that that's probably going to be another factor because they're trying to show off you cancel everything. So grand total, 1 on top, and just that little thing on the bottom.
I got it back.
You good on that? That answer your question satisfactorily?
Yeah.
Anybody else? Same kind of thing happens, like I think on 37, 38, when you get to that next section. I think 37, 38,
Yeah.
there's a cube that makes a mess, but the mess is already elsewhere in the problem, and they just vaporize. Anybody else? 249, 250, anything on that homework that had you stuck? 23. So 23, were you able on the first one, top, to factor the cube?
I don't do that.
Okay. Do you know how to factor cubes?
Yeah.
Okay, so first top, factor that as a cube.
We C plus 2.
Yep.
C squared minus 2C
Yep.
plus 1.
Yep. That thing that you just got done saying will cancel the right bottom.
Alright.
The thing you just said is over there. Do you see that match?
Yeah.
Are you okay to factor the other things that do factor on that?
Yeah.
And you're gonna get some nice cancels. Is that enough of a tip? Okay. Yeah, just had to factor that cube, that's all.
Alright.
Anybody else, anything, 249 that had you temporarily stuck? Seemed like factoring cubes was not our favorite thing there for yesterday. Anything? Okay, well, let's shut that down.